Hello. This is a video on how to multiply higher radicals. So we're multiplying radicals that have higher roots. All right, this is example 1. It's pretty easy. That's because they're the same root. So all you do is just multiply these numbers. 3 times 7 gives you the cube root of 21. That's pretty easy. It's not going to simplify because the only factors it has are 3 and 7. So there's no perfect cube root in it. And if you did the factoring tree, you'd only get 3 and 7 and nothing would come out. The next one, this is the same thing, and I demonstrated doing it. You got the 4th root, so you just multiply 9 times 32, you get 288. Now, when you come down and do the factoring tree, you have 2 factors that were already given to you. They're the numbers you multiplied to reach this number. You just bring them down. We know that 32 has 5 2s, so we just write those out, and 9 is 3 times 3, and it's the 4th root. So to simplify this, you need 4 2s. So we have 4 2s, we brought 2 out, and we multiply the remaining numbers. So 2 times 3 times 3 is 18, and that's all there is to that one. So now this one, this is involving some Algebra 1 and involving our first unit of the year. And so we have the square root of y plus z and the square root of y minus z. You just multiply those doing what we've been doing. We just take this, y times y is y squared, y times negative z is negative yz, z times y is yz positive, and z times negative z is negative z squared. Now you add your like terms in the middle and they cancel one another out and become 0. So this is just the square root of y squared minus z squared. Pretty simple, nothing to simplify there. All right, then we go to the next one. This is where, and it's still pretty simple because they're the same roots. So remember what I taught you earlier when multiplying radicals. You multiply outside numbers with outside, meaning numbers that are not underneath the radical, and inside numbers with inside. So there is an understood 1 here. So, and I'm going to distribute. I'm going to do the cube root of 2 times the cube root of 12. And so 2 times 12 is 24, and then we do the factoring tree again. You have, and I used 8 and 3. I should have used 2 and 12 and let you see it that way, but that's okay. And then there are 3 2s, and since it's a cube root, I'm bringing out the 2, so that gives me 2 cube roots of 3. And then I come over and I do this one, the cube root of 2 times 3 cube roots of 54. Understood 1 times 3 is 3. Cube root of 2 times the cube root of 54 is a cube root of 108 when you multiply those numbers. And I just used 2 and 54, which was provided. I did the factoring tree, 9 times 6. 9 is 3 times 3, 6 is 2 times 3. And it takes 3 to bring one number out because my root is 3. So the 3 is coming out. Don't forget the 3 you already have here. You have a negative 3. So a negative 3 times the 3 that came out, and then the cube root of 2. Oh, I see a mistake. The cube root of 4 is right there. We have 2 times 2, that's 4. All right, which is 2 cube roots of 3 minus 9 cube roots of 4. It's funny, it's just like I tell you, when you talk something out with math, you see your mistake. So I don't know how I forgot that. I had it circled to keep from forgetting it. But anyway, you see if I can do it, you can do it. All right. Now, this is the kind you've not done or seen. We have the cube root of 2 times the 4th root of 3. We can't add these numbers. Just like with polynomials, we can't add numbers which are not like polynomials, which are not like terms that are not like, but we can multiply them. The same is true with radicals. We can't add these two, but we can certainly multiply them. And we kind of think of it like it's a fraction. And so we find the common denominator. The common denominator between 3 and 4 is 12. So 12 is my common denominator, and to get to 12, I multiply the 3 times 4 and the 4 by 3. So whatever I multiply the radical by to get here, I have to multiply the number underneath the radical by the same thing. So this is 2 to the first power and 3 to the first power. So 1 times 4 is 4. So I multiply the exponents by the same thing that I multiply the radical by. So this is the 12th root of 2 to the 4th power. Same thing here. 4 times 3 is 12, so 3 to the first. So 1 times 3 is 3. So I have 2 to the 4th times 3 to the 3rd, and I wrote them together underneath the same radical. And then did 16 times 27, or you just put that in your calculator, you'll get the 432. Now, I could go through the motions of doing the simplification here, but there's no need. I know I have 4 2s, and I know I have 3 3s, and that's not 12 of the same prime number. So nothing's going to come out, so that's just my answer. It's the 12th root of 432. Okay, same thing here. You want to find the common denominator or the common root in between 3 and 2. That's 6. So I'm going to multiply these by 2 and multiply that one by 3. Now, remember, I'm multiplying the exponent by that number. So 3 times 2 is 6, and 1 times 2 is 2, so this is 6 to the 2nd power. 2 times 3 is 6, and so 1 times 3 is 2 to the 3rd power. Now, I put that in my calculator and got the 6th root of 288. Now, I wrote this one out so you could see. I have 3 2s, and then I took the 2 6s and put them here and broke them down. It didn't help me. I have 3 2s, 4, 5. I don't have enough to simplify, so it just is the 6th root of 288. Now, I've got variables. It's the same thing. Don't get confused by it. I've got a 3, I've got a 2. So the common denominator is 6, so I put the 6th root here. And I multiplied this one by 2. So I'm going to multiply all of the exponents by 2. I multiplied this one by 3, and I'm going to multiply all those exponents by 3. So that's going to give me 2 times 2 is 4, 1 times 2 is 2. So the 6th root of x to the 4th y squared. And then this is the 2nd root multiplying by 3. So exponent of 1, exponent of 1. 1 times 3 is 3, 1 times 3 is 3. Now, when you multiply with exponents, and you may not remember this because it's been since 8th grade since you had exponents, but when multiplying these, you add. So it's the 6th root of 4 plus 3 is x to the 7th power and y to the 5th power. Now, I have to simplify this. I have 6 x's in here, so I'm bringing 1 out, and 6 goes into 7 one time with 1 left over, and then I still have 5 because 6 doesn't go into 5. So that's the first term simplified. Now I go up and I take the second one. I'm going to take this one times that, and I wrote them out, number 1, number 2. So number 2 is the cube root of x squared y times the negative 4th root of x to the 3rd y to the 5th. The common denominator there is 12, so my common root is 12. I'm going to multiply these by 4. Remember, you have an understood one here. 2 times 4 is 8. 1 times 4 is 4. That gave me this one. And then 3 times 3 is 9. 5 times 3 is 15. That gave me this one. All right, it's the 12th root. So, and a positive times a negative is a negative. So it's negative 12th root of, and add these, x to the 17th power, y to the 19th power. Now, I do have 12 in each of these. So 12 goes into 17 one time with 5 left over. 17 minus 12 is 5. 12 goes into 19 one time with 7 left over. 19 minus 12 is 7. So this is my second term. So when you put them all together, you get x onto the 6th root of x y to the 5th minus xy onto the 12th root of x to the 5th y to the 7th. Thank you.